Hi everyone. Welcome back to Dave's Math channel. This is my 12th lesson, probably my last on the sub-series on derivatives of my series on first year calculus. And today I'm going to talk about how to compute derivatives of logarithms. Anyway, let's begin. So here's just an enlarged version of what was the formulas in the middle of the last slide. These are the formulas for the derivative of the natural logarithm. You see it's very simple. Derivative of natural logarithm is just 1 over x. And for common logarithms, or base A logarithm if you like, it's not too much different. The only difference is you have a factor of the natural logarithm at a in the denominator along with x. So those are the formulas. And how do we derive these formulas? Well, it's really not that difficult. The first thing we note is that the natural logarithm is the inverse of the exponential function, e to the x. So it's probably a good idea to first derive a formula for the derivative of inverses. If we know the derivative of a given function f of x, where f is an arbitrary differentiable function, how do we find the derivative of its inverse? Well, it's actually pretty easy. We can apply the chain rule. So what we do is we first note that f of x is really just the same as f of f inverse of x, because f undoes the action of the inverse. So that's pretty obvious. And now, notice that we have a composition here on the left, f of f inverse. We know how to take the derivative of that. And so we just do that. The formula for the derivative, remember the derivative of f of g of x is f prime of g of x times g prime of x. So that's what we're doing on the left side. We have f prime of f inverse of x, that's our g of x. And now we multiply that by the derivative of g of x, which is really just the derivative of f inverse of x. That's the thing we want to find. And now on the right side, note that we're taking the derivative of x, and we all know the derivative of x is 1. So now we have the product of two things, one of which we want to find, equal to 1. So all we have to do is divide by the thing on the left, and that's the last step. So the formula we obtain when we do that is the derivative of the inverse of f is equal to 1 over f prime of f inverse. That's the formula. Voila. Pretty nice. And now we can apply this formula to compute the derivative of the logarithm, because the logarithm is just the inverse of e to the x. So we apply this inverse formula we just derived. So we know it's equal to 1 over f prime of f inverse of x, where now f of x is e to the x, and f prime of x is also e to the x, because it's equal to its own derivative. And f inverse of x is log of x. So we just plug everything in here. When we do that, we get 1 over e to the log of x, but we know that e to the log of x is nothing but x. So when we're done, we just get 1 over x. That's how you can derive this formula. Anyway, so that's the derivative of the natural logarithm. Very simple, just 1 over x. And if we wanted to compute the derivative of common logarithm, log to base b, here I'm using b instead of a. I prefer to use b, I guess, just because b stands for base. But anyway, how do we do that? Well, the way we do it is we first note that the common logarithm, the log to base b of x, can be rewritten as the natural logarithm of x over the natural logarithm of b. This is an identity. You might have remembered this when you were first learning about logarithms, in high school algebra. Ln is really just log to base e. In general, there's another identity. I think this says log to base b of c is equal to log of base a of c divided by log to base a of b. Here, a is just e. So that's an identity. We didn't have to do any calculus to get that. And now, the thing we note here is that the base b logarithm of x is really just proportional to the natural logarithm of x, and that constant proportionality is just 1 over the natural logarithm of b. So now, computing the derivative of the base b logarithm of x is easy. It's just the derivative of ln x over ln b, but since ln b is a constant, we can factor it. So we get 1 over ln b times the derivative of log x. We just computed the derivative of log of x, that was 1 over x. So we just get 1 over log b times 1 over x, or if you like, 1 over x ln b. That's how you derive that formula. So anyway, that's how to compute derivatives of logarithms, both common logarithms and natural logarithms. Pretty simple. And that concludes this video. And like I said, this probably concludes, at least for now, my series on derivatives. I think we've computed the derivatives of every kind of elementary function we can think of, and that's all that's really part of this course. So anyway, that concludes my video. Thank you for watching. Long live math, and I'll see you guys next time. Bye.